Good morning, everyone. Some of you, good afternoon. So sorry I can't be there with you, but I am here to teach you a lesson via technology. So super thankful for that I have the means to do that for you. I want you to know that I'm here supporting you. What we're working on today is chapter 9 from your textbook. That's on page 546. 546. Okay, what we're working on are quadratics. The U, up and down, the U. Okay, also known as parabolas. The standard we're working on has to do with functions. Okay, so you guys should be able to graph linear functions, lines, y equals mx plus b, right? As well as quadratics. So you should be able to graph parabolas on a coordinate plane, as well as identify the minimums, the maximums, as well as the intercepts. So keyword there, intercept, got to remember what that means. So think back to so long ago, like a month or two, but it seems like forever. An intercept is where it's actually crossing either the y-axis or the x-axis, the point where it crosses one of the lines on the coordinate graph, the y-axis or the x-axis. Right now we're going to be focusing primarily on x-intercepts, and guess what? You remember factoring trinomials? Remember how I told you you could either factor or solve? When you solve the x equals, guess what those were? The intercepts as well. I know, crazy. Everything totally interrelates to one another from what we were doing, ax squared plus bx plus c, to what we are doing now, which is graphing them. So, chapter 8, we learned to factor them, right? Factor, which is basically undoing double distributing. Now we're going to take that and we're going to start graphing them. Okay, so what we did is completely dependent on, or rather what we are doing is dependent on what we did. So it's almost like a function there, right? My y is dependent on my x. So what we're doing now is dependent on what we did before. Okay? So here we go. Quadratics. All right, what do we know about quadratics? A quadratic is also known as a parabola. We're focusing primarily on when it's going vertical. Okay, so up or down. All right, from chapter 9. Quadratic functions. A function is typically, we remember it as y equals mx plus b. Every x has one y, right? That's faithful functions. There's an input and an output, which makes sense, right? Because to have a formula like this, that means no matter what I substitute in, I will always get a single value. That's what we're looking at. We're talking about quadratics. These are also known as parabolas. I will use that word interchangeably. Quadratic means parabola, so I will use them and they mean the same thing. In this case, we'll also be discussing when we have a minima or minimum and a maximum, right? And in simple terms, we learn this when there's a floor, it's a minimum. When there's a roof, there's a max, okay? Your minimum and your maximum are also known as your vertex, because really that is the single point that the parabola reflects, because we know that parabolas are symmetric. You should be able to fold one half onto the other. This half right here should be congruent or symmetric to this half. It should fold over onto it. So what we're working on today, right, or in this particular section, is notice we're reflecting left and right. So it looks like a reflection over the y-axis. So to reflect over the y-axis means we're also intersecting the x. Why am I telling you that? Because notice my minimum is a single point here, my vertex, written as x, comma, y. The vertex is in the middle of the parabola. For something to reflect, it reflects at the middle point, the point that's equidistant. That also then means that the line of reflection, known as the axis of symmetry, must correlate to the x value of my vertex. Because notice here, the line of symmetry is passing through the vertex. The line of symmetry is passing through the x-axis. Therefore, the axis of symmetry is going to be the same as the x-coordinate of my vertex. The x-coordinate can be solved using x equals negative b over 2a. Negative b over 2a. b, a. Trinomials. Right? Crazy. It all is completely interrelated. So let me just put that there for you real quick. So some of you I know are like, wait, don't go, I'm writing. There it is. Okay, maximum minimums, parabola, quadratics, functions, vertex, axis of symmetry, lots of terminology, and we've got it here. Okay, there we go. So, again, a quadratic is in the form of y equals ax squared plus bx plus c. We know this. That is known as standard form. Thought bubble. Is that trinomials? Yes, it is. It's exactly what we're doing in chapter 8. The parent function of a quadratic. And when I say parent, that means like the original, right? That is the foundation of a quadratic. How it changes, moves right or left or up and down, those are the changes that occur. But the parent is where it always originally begins. So it's sort of like the seed, foundation, the original OG there. And so this is my original. The starting point would be the origin, the 0, 0. That's in the form of y equals ax squared. So notice, what are we missing? There's no bx, there's no c. Y equals ax squared. Well, what would, for there to be no bx or a c, they don't just disappear. What number would they have to be to just not be present anymore? I know some of you got it. 0. For something to just all of a sudden disappear, the only way it actually disappears is if it's equivalent to 0, right? So remember how I could find the vertex by doing this, negative b over 2a? Well, if my b is 0, what's 0 divided by any number? 0. Exactly. So if my x is 0, then my y, no matter what I plug into it, would also be 0. So the parent function, tying it together, parent function means that the original graph, the vertex, is on the origin, the 0, 0. Got it? Okay. Again, remember, you guys can rewatch these if you need to. So here we go. There's my parent function, y equals ax squared. We could also write it as a function. F of x is equal to x squared. Do you remember back when we were working on these in semester 1, the whole x minus h plus k thing, where I took something on a graph, and if it moved right or left, that was the whole minus h, and if it moved up or down, it was a plus k? That's exactly what we're doing again. We're applying all of that again. All right? So there we go. That's where we are so far. Looking at here some examples of parabolas. I can see that this first one is a positive. Why? Because it's going up. This one is a positive. Why? Because it's going up. This one's a negative. Why? Because it's going down, right? Okay, so take a look here. Now I want to dissect. What do I know about each of these graphs? Okay, so for instance, what I'm looking for is, first, let's identify what is the vertex. Well, the vertex for this guy is 0, because it did not go left or right, negative 4. The vertex is 0, negative 4. Well, is it a maximum or a minimum? It's a minima. Why is it a minima? Because it's the base, it's the floor. So the vertex is 0, negative 4, and it's a minima here, okay? So we're focusing on right now. So I'm going to go ahead and write that. This is, the vertex is 0, negative 4, and this is a minima. All right, the next one, I could see this also has a minima right here. because there is a floor to it, and this would be going to the right 3 and up 1. So this vertex would be 3, 1, and I would call it a minima. And this one right here would be 0, 1, 2, 3, 4, 5, 6, 7. 0, 7, and that one is a maxima. Why is it a maxima? Well, because it's a roof, right? There is a roof to it, so it's a maxima. There's a max point that we can go to, and it can go forever down, which really it's going forever down and left and right. Keep that in mind. So when there is a maxima, that means there is a limitation on your range, but it can go forever down, and it's also increasing forever right and left. Why am I bringing that up? Do you remember domain and ranges? Yes, we're tying all that back in. I know you're like, no, but yes. So we're going to look at the one that has the maxima. All right, again, I said that was, okay, that was 0, 7. That is a maximum. I'm going to talk now about its domain and its range. Well, the domain is how it goes left or right. Well, when a graph is going up or down like this, that means my domain and range, there's no limitation because it's going forever like this. So notice, what are my arms doing? They're going forever out. So there's no limitation on how it goes right or left because it's going forever out, forever and ever and ever and ever and ever, right? Same thing with going up or down. I'm starting here and I'm going forever out. So when it's up or down, that means my domain has no limitation. So my domain I would write as all real numbers. My range, however, is how it's going up or down. Well, to have a minimum means there must be a limit. To have a maximum means there must be a limit on how it goes up or down because obviously there's a roof here. So if there's a maximum, that means the y can go forever down past this point. If there's a minimum, that means the y can go up forever up past this point. So there is a limitation on my range. So if there's a roof or a floor, a max and min, you know there's a limitation on your range, which is your y. So that looks like this. In this case, since it's going forever down, and it was at 0, 7, my y value is the 7. So that means my range can go y is less than or equal to 7. Go ahead and take a look at that and let it sort of resonate for you. Why are we doing this? Because notice right here, there is my maximum, but this graph is going forever down and forever left and right. So that means my range can go from this 7 forever down. So y is less than or equal to 7 because it's going to keep going down. So if there's a minimum, so in this case, my minimum, my domain would be all real numbers going forever left and right. My range then would be, it could be y is greater than or equal to -4. How come this one's greater than? Because this one's going forever up at the -4, right? So I'm going to say, okay, for this first one, my domain is all real numbers, and my range is y is going to be greater than or equal to -4, again, because it's going forever up. So when it is going up, it's going to be greater than whatever the y value is of the vertex. When it's going down, its y is going to be less than whatever the y value of the vertex is or equal to. Okay? A lot of stuff kind of combined into one. I'm really trying to help you understand how what we've done is applied to what we're doing. So you can pull all the knowledge that we already know into what we're doing right now, so it is far less confusing, okay? Some of you may want to go ahead and use your past notes, refresh your memory on those past notes on what we did with polynomials and moving the graphs left and right, up and down. Maximum, minimum, maximum. The u is known as a parabola. Y equals ax squared is my parent function. My vertex is going to be either the max or min. And the x value of my vertex is going to completely correlate with the axis of symmetry. And that is how the parabola is repeated on one side and then the other. So we're going to next start graphing these using a function table.